Hi, good evening, everyone. Am I audible?
Yes, sir.
Okay, very nice. Just give me a second. I'll share my screen. Okay, I hope my screen is visible.
Yes, sir.
Okay. Good evening, everyone. Thanks for joining in. And this is basically the revision session for your end term quiz. And the main focus for this revision session is week 9 and week 10. Because we have already done the revision sessions for quiz 1, in which we had covered week 1 to 4 in detail with the concepts and the PYPs, and same thing we had done for the quiz 2 also. So in case of you having any doubt regarding those concepts, you can revisit those sessions and you can get your doubts clarified. So keeping the time constraint in mind, I have kept only week 9 and week 10. So we will follow the same regime which we followed during the earlier revision sessions. We will cover first the important concepts of week 9 and week 10, and thereafter we will take on some questions from the PYPs. So to implement those concepts. So the week 9 basically was about word representations, and it started with the corpus. What is the meaning of corpus? So corpus is a collection of words or statements. A vocabulary is when we identify the unique words in that corpus, that is known as a vocabulary. And the one of the main challenge the computer science fraternity was facing, that how to represent a word. So one of the most naive idea was that that if you have got, for example, 100 unique words in a vocabulary or a dictionary, then you convert every word into one hot vector representation. So, like, what do I mean by that? That if you have got, for example, I'm just taking one very simple example, that we have got only vocabulary is just he sat on a chair. So this is the entire vocabulary, for example. So what do? You represent every word with one hot representation. So sat will become 0, 1, 0, 0, and like that. But there is a one major problem with this representation. First of all, we know that our vocabulary sizes are very very large, so that is the main disadvantage of this approach. And second, the disadvantage is that by doing this, we don't find any similarity between words. Between words is not found. It's not found. Because for similarity, if you do the dot product of this word with this word, it will come 0. Okay, so, or whereas if we had she also here, then we had something, so he or she might be related, but by doing this we cannot find any similarity. So two problems: one is very large size, and second, similarity not captured. Now, from that, we can do distributed representation of words to address some of these problems. So, what we did, that we developed a co-occurrence matrix. That in these statements we found that how many times those two words they were occurring in a window size. So this window size can be k is equal to 1 up to anything. In fact, like Google, they follow a very large window size. So k is equal to 1 means that you will have a window size if this is the word. So in the co-occurrence, this will include this and this will include this. As you go to k is equal to 2, and you have got, for example, the words are A, B, C, D, E, and if k is equal to 2, then you will get A, B, A, C. Now you start 2 on either side. So for A here, For B, it will become A and CD. For C, it will become AB and DE. For D, it will become BC and E. And for E, it will become CD. So get this concept here because there are some PYPs where this concept has been checked. Okay, and thereafter what they did that after making the co-occurrence matrix, for example, this is one example which I have given. Oh, it is straight away from the lecture. And I have built one more example. This is, for example, this is the corpus, entire corpus. Delhi is capital of India, Paris is capital of France, India and France are partners. Delhi resembles Paris, just for example purpose, and India resembles France, just for the so how to develop that co-occurrence matrix? So we see, and I have taken k is equal to, for example, 2. That there, it is going from here to here. How many times? So, and what I have done, I have ignored the common words, which are known as the stop words. We know that from our MLP. So this is of, and are, they are ignored. So this will become Delhi capital India, Paris capital France, and that's how we develop the co-occurrence matrix. So we can see from here that India and France, they are occurring 2 times, one in third statement and second time in fifth statement. So this is known as the co-occurrence. Now from this co-occurrence, we develop something called PMI matrix, or it is a point-wise mutual information. Point-wise mutual information, it is calculated as log count of the words which are occurring twice. For example, if I have to find for India and France for this PMI, so this will become 2. Your N becomes 1, 2, 3, 4, 5, 6, 7. And how many times India and France, they are occurring individually. So India is occurring, for example, 2 to 4 to 6, 3 times. And France is also occurring 3 times. So this is how we do the PMI calculation. Now, one of the main problem with the PMI is that if, for example, there is 0, that it is not occurring. Any doubt again, anyone?
Yes, sir. Can you repeat the last part, sir? PMI.
Okay. Just hold on. Okay, so we have made the co-occurrence matrix. I'm just giving an example. So here I had India, and here is capital, France, and here is France, and all these words. So I have to find, for example, PMI for India and France. So formula is log number of times India and France they are occurring together. Okay, count WC into N. N is the number of words divided by count of W. How many times India is coming? How many times France is coming? Okay, so that's how we got log 2 into 7, and India was occurring 3 times, France was occurring 3 times, so it becomes log 14 by 9, which gives us one number. Is that clear?
Yes, sir. Okay.
Okay. Now, a point of caution for all of you, there have been some PYPs where this and which you have found, maybe we have found, okay, for example, 7. But in the question, they might give you that n is equal to 9. So it should not bother you. So you apply that in formula because these values you get from your co-occurrence matrix. Okay. Is that clear? Shall we go
Yes,
ahead?
sir.
Anybody thumbs up? Okay, very nice. Now one of the main problem with the PMI is that when we take the log and for example this count WC is 0. So then this log 0 becomes minus infinity. So from there the concept came of PPMI, positive point wise mutual information, and PPMI is nothing. It is equal to PMI if PMI is greater than 0. Otherwise it is 0. So all the numbers will become positive. So that is PPMI. So still in the PPMI also now we have found, so if we calculate we will get some PMIs. So this is the co-occurrence matrix and these are the PMIs. Okay, so this is with the PMI. Now again, the problem is that first of all, high dimensionality remains our problem, and this matrix will be very sparse because the vocab size is very large. Okay, vocabulary size, so lots of zeros will be there. So a solution was given that if you do a SVD, singular vector decomposition on this, we can reduce dimensionality of this matrix. So that we know from our maths foundations and plus MLT how to do the SVD. But a very unique thing emerged when we did the SVD. So for example, we how do we do the SVD? We do the SVD this XPPMI m into n is equal to matrix U, which is dimension m into k, this k into k, and v k into n. Now, when we did this singular value decomposition and we took this, for example, the first part, which is known as the W word, then we realized that where the PPMI values were zero, there also some semantic relationships emerged. Okay, so here earlier human and user was zero, but however here some relationship emerged again. Similarly between system and machine. So this is one of the technique which was used, and when you take this u n into k into sigma, this is like a word representation. So I forgot to mention that when you make a co-occurrence matrix and when you take the PPMI, the row part which is there, it is known as the word representation. That this for which is there, it will be word. And the column which is there from the top, it is known as word context. Okay. So these are the word context value for system with different words, and these are the word for with different other words. So this first part, okay, when you do the SVD, this represents the word representation, and the VT which is there k into n, it is the word context representation. Okay. Now, so here we found a method by which we can calculate the word embeddings. This word and word context is nothing but these are the word embeddings which we generally read, okay, that for this RNN we got the word embeddings and all that. So if you have got the entire vocabulary and you have got some corpus, that corpus we can take from Wikipedia or from web scraping, so then we can build our word embeddings using this also. Okay, so here what we have done, we have reduced the dimensionality and we have been able to find the word embeddings. Now what happened after that? So it is a straight away mathematical calculation computations using SVD. Now entered the neural network. So using the neural network, there are two famous models to find the word embeddings. What is the continuous bag of words model, and the second is skipgram, and they are based on the forward neural network. So what continuous bag of word does, it predicts the nth word, have to predict the next word after this. So we have got the entire corpus, we know the probability that this is the word which comes after this word, so we train on that. So what do we do? For example, we know that after set, on is the most common word which comes. So we have to say feed the vector representation of set, for example 00100. Here is the dimensionality reduction method. For example, here I can take k is equal to 2, for example, in this example, and this is weight matrix 1, this is weight matrix 2, and now I get an output using the softmax on this. So if you see here, this W1 which is there, it is akin to word context. And why it is akin to word context? Because this W1 size which is there, this is 5 into 1 and this is 2 into 1. So W1 size is 2 into 5. And when you see 2 into 5, The only column which contributes towards this H is this column, and the word context also was the column. So this is akin to word context. Whereas here, when you take W2, it is akin to W word, because here the row which is there, it contributes towards this number. So by maximizing this, we what do we do? We find W1, W2, straight away neural network problem. We do back propagation, we do the gradient calculations, and we find W1 and W2. So we can say that continuous bag of words, using this predicting the next word after a word, we find the word embeddings. This W1 and W2 are nothing, but they are the word embeddings. Any problem in understanding till now for this? Anyone? Pipe up. Okay, shall I go ahead?
Yes, sir.
Okay, very nice. Thank you. Okay. So I'm slightly going fast, but you can interject anywhere you don't understand. So because I'll be focusing more on the PYPs. So I taken another example, CBOW. So CBOW, you have got 4 words and you have to predict the 5th word. So remember the size in CBOW. For example, this word is, one word is represented by 100 into 1. This size is 50 into 1. This size will be 100 into 1. So there are how many parameters will be there in this model? This is 100 into 1. 100 into 1.
100 into 50 and 50 into 100.
Okay, it will be 4 into 100. Okay, into 50 plus 50 into 100. Is this clear? See, these are the 4 words. Is that clear? Anyone doubt in this?
How it is again 4, because if there is 100 into 1 size of
But
vocabulary.
But we are feeding 4 words. We are predict 5th word of given 4 words. So there are the 4 words: 100, 100, 100, 100. Is that clear? Okay? Anyone else having doubt in this? See, this is a normal neural network where this, if you take the combined size, it is 400 into 1. You're feeding 4 words. So it is, for example, 001. It is very large size. So here it will be 1. Here it will be 1, 1. Here it will be 1, 1, 1. Here it will be 1, 1, 1. And we are training. For example, I'll give the same example that corpus size is your walk-up size is 100. And you know that Delhi river is Yamuna river. Okay, for example, okay, I'm just giving this one. Or so we know that Yamuna comes the 5th word by our corpus. So we now train these word embeddings so that the Yamuna is predicted. And here is the, so when we'll come to skip gram, again I will revisit this concept again. So just remember this, in CBOW, the input size is more if there are more than 1 words and we are predicting the target word. Okay, we are feeding the context words and we are predicting the target word. This is CBOW, and when we find W1 and W2, this is akin to word context and this is akin to word. And they are nothing but they are the word embeddings. Okay. Skip gram model is just opposite. So what it does, it predicts the context words given a target word. So its input is single word and it finds that what are the probabilities of other words which are in the context. So here you see, here W1 becomes akin to word, and W2 becomes akin to word context. So in this case, again, I will give you the same example. In case this is 100 into 1, this is 50 into 1. So this will become 100 into 1, 100 into 1, 100 into 1, 100 into 1. So how many total number of parameters will be?
100 into 50 plus 104.
Okay. Okay. So, okay. Now the concept here that both in CBOW and skipgram we use softmax here. We know that softmax is used, okay, for the classification.
Excuse me,
Yes, please go ahead.
sir. Are we implementing 1-hot encoding for every word?
Yes.
Okay, so that means out of 100 word we choose only 4. Am I right?
See, from the corpus we know that if I have got this target word, okay, for example, again I'll give you the example that this is Yamuna, then I know that its context words from the corpus are, for example, Delhi, India, river, or just take an example.
Taj Mahal.
Red Fort. Okay, yeah, Taj Mahal is a nice example. So we know that these are the words which happen with Yamuna the most. Okay, Yamuna representation is, for example, 0, 0, 0, 0, 1 and 0. So these are 100. This representation Delhi will also be some like a 1, all 0. This also will be there. So by training, what do we do in the neural network? We update the W's. Okay, and this becomes the word embedding. And this is the W word, and this is akin to word context. So all these companies, Google and all that, okay, companies, what they have done, they have built their word embeddings using these models. Okay.
Okay, sir. So
Okay.
that means here we are reference like taking reference from 100 word. Like there is a 100.
Yes,
So
yes,
like
yes. So unique words, okay, your walk-up size is 100. Okay. Whereas in actual, okay, you know that okay, it is very, very large. Okay.
okay, sir. Thank you.
Yeah. So now the problem in this, okay, both CBOW and skipgram is the computational complexity because we are using softmax as a output function, and we know that this exponential which is there, e to power a plus e to power b and lot of e's, it is very, very computationally heavy. So there are three techniques which are used to overcome this problem. One is negative sampling. Negative sampling, what happens that this is a technique used to make a training process efficient and scalable. It is used in skipgram with every positive pair, for example, Delhi, Yamuna. What it does, it also finds some negative sampling. You know that Delhi and any river, okay, for example, Thames, will never occur together. So this is known as a negative sampling. So you do negative sampling with this, you train. So other than training on the entire vocab, you are training on some negative samples only, and that's how you get the vocab size. Okay, just remember theoretical part. Okay, if it comes okay for your multiple questions. Uh, for understanding part, professor has covered it in detail, and there are a lot of online resources also you can go. So I just wanted to cover this for the completeness purpose. The second is contrast estimation. Contrast estimation is a general form of from where this negative sampling has come. Contrast estimation involves training a model by comparing positive samples with negative samples to help the model learn to differentiate between correct and incorrect data samples. And just negative sampling is one type of contrast estimation. The third is hierarchical softmax, in which what you do, what you uh, the entire vocab which is there. So you've got a vocab. So what do? You make a binary tree. So binary tree we know how to build. And instead of calculating the probability using the softmax, what do? You traverse through that binary tree in which the word is at the leaf node and you find the probability. So that is computationally quite efficient and much more efficient than softmax. And generally this method along with the negative sampling is used to find the word embeddings uh, in most of the cases. Then there was a term which came during the lecture was global vectors for word representation. What it does, it uses both count-based method and it learns also. So in the count-based method we saw in the SVD, we are just doing the calculation. We are doing the singular value decomposition, finding the word and word context, which are the word embeddings. Here, depending on the type or more frequent pairs and all that, what do? We depreciate some pairs. So it does the learning part also. It does not have any, neural network type, but there is an objective function and you do the optimization over that. So that is GLOW for understanding part. Now with this, I have completed the main concepts of week 9. Anyone having any doubt or any generic doubt till now?
No, sir.
Okay, very nice. So we go to PYP. So this is a question. Suppose you have a vocabulary of 5,000 unique words. You want to train a CBOW model with a window size of 3 on each side and with an embedding dimension of 500. How many parameters will be there? Can anybody tell me quickly? It's a 30 seconds question.
It is 5,000 multiplied by 500.
Very nice, very nice. Everybody understood this question? Anybody having any doubt?
Clear, sir. Clear.
Okay. So remember in CBOW, what do? We feed one word and we have output one word. So there are 5,000 unique words are there. So size of input is 5,000, output is 5,000, and they are asking what is how many parameters will be there in the embedding layer. So this is the embedding layer. So this is nothing but 5,000 into 5,000. Now in this question, if they ask you find total number of parameters, then what will be the answer?
So again multiply by 2.
Yes, very nice. Okay, so now this is clear. Okay.
Sir, why we multiply by 2?
Because here is 5,000 into 500, and here again 500 into 5,000.
Okay, sir, thank you.
Okay.
So window size does not affect the number of parameters.
Which one? Which one?
So given it is given that window size of 3, so won't be given the input for 3 words?
No, in this question it is not like so. So in CBW, if the question comes again in the PYP, consider input only one word. Okay. Unless specifically they say that predict the target word after 3 words. Okay. So unless this is specified, just follow this only. Okay, what will happen if it will become predict target after 3 words? So we have seen that this will become 1500 into 500 straight away. Okay.
Sir, how do we know that it is asking for all parameters or only half parameters?
See, here it is written embedding layer.
Okay, I got it, sir.
Okay, so this is embedding layer.
Thank you, sir.
Okay, and this is the what is there? This is output layer.
Sir, can you explain, like, if they ask predict target word after 3 words, then what we have to do?
Okay, so we had seen earlier. I'll go here. Okay, just hold on. So if it is after 3 words, so this is one word, this is another word, this is another word, and size is 1500, 1500, 1500. You feed this to 500. Okay, output is 1500.
It is 5,000, sir.
Okay, sorry. who's this again? Kindly mute your mic, please. Okay, so this is 5,000. So when the three words, so embedding layer size will become how much? 15,000 into 500. Okay.
Yes, sir. Clear.
Okay. Yeah. Okay. So, okay, this is another question. Suppose you have a vocabulary of 10,000 unique words and you want to train a CBOW model with window size of 2 and with an embedding dimension of 300. It is the same question, just figures are different. So I will not be solving it. You can solve this. So we go to next question. Assume that your CBOW model outputs a probability distribution over a vocabulary of 20,000 words for a given context. If the correct target word is word number 150 and the model's predicted probability for this word is 0.02, calculate the cross entropy loss for this prediction. So how to approach this problem? This is a normal forward neural network. So what you do have to do, we know that there is an input which is of size 20,000. So we know that output will also be the size of how much? 20,000. The correct target word is word 150. So some correct target word is there. It does not matter where it is. It can be anywhere. But for that, the value will be 1 here. Rest all will be zeros. Now for that, it has predicted probability of 0.02. Okay. So what is the loss? Loss, okay, we know that cross entropy loss is minus
ln of
Why?
predicted probabilities.
Very good. So it will become minus ln of 0.02. Okay. And you'll get the answer. So understand the question, and when you apply the concept, it becomes a just 30 seconds question. Okay. Anyone, any doubt in this question?
No, sir.
Okay. Okay, very nice. Okay, this is another question. In a skip-gram model with a window size of 2 on each side, how many unique pairs of target and context words will be generated for the following sentence? The idea is to die young as late as possible. Okay, so here your concept of that window size comes, and how do you solve it? So like I had covered during the concepts, so window size is 2. It means every word you have to see 2 left and 2 right. So for the, your, what will the and idea, the is, okay, is it clear? Idea,
Yes, sir.
idea, it will become idea. Remember this, in skipgram, what do we do? This is the target word and this is the context word. Okay, so the idea and idea the, they both are different, they are unique. Remember this. Okay,
Okay, sir.
because this is target word and this is context word. We say if I feed the, idea will come. Okay, so now for idea, you find idea the, idea is, idea to. So you do this. So this I have done here for the demonstration purpose. So I have taken this this. So the idea is to, so for every word you have to find target and context, target and context. So there is only one place where as late as here. So you will find as occurring twice, late as occurring twice, and as late occurring twice. So total there were 34. When you subtract 3 non-unique, so you get the answer 31. Okay, so be ready for this kind of question. This takes some time, but you know the trick. So the calculation is very, very easy. Okay, so Any doubt in this question? Anyone? How to
Can
solve
you
it?
please repeat it once more?
Yeah, okay. So,
Thank you.
yeah. So basically, this is the sentence. The idea is to die young as late as possible. Window size is 2. The model is skipgram. So in skipgram, what do? We have got target word and we have got context word. So for each word, for example, the, so you see to this side and to this side. So on the left, there is nothing. So it will become the idea, the is. Now you come to idea. Idea has got 1 here and 2 here. It will become idea the left side. Idea is idea 2. Now you come to is. Is has got 2 here. So it will become is the, is idea, is 2, is die. Now you keep on doing for all. So you will get a collection. So this is a collection which you get. Now the idea and idea the, they are two different pairs because this is a target word and this is a context word. But when you come here as, okay, for example, here you come, so you will get as die, as young, as late as possible. Okay. Now you come to late, so you will get late.
So it will be as instead of
But
as.
as
sorry,
is
sorry.
already there, right?
As.
Oh, will we repeat the words as well in
Yes,
this?
yes.
Okay.
Okay. So here you will find now here okay, late, young, late as, and here also it will come late as. So you can see these are two, not only one unique is there. Is that clear?
Yeah.
And when you do with this s, again you will get s and s. So this is, you will cut it. Okay. And
So all
as
the distinct ones, right?
yeah. So as
Alright.
late, as, and late as, these are the 3 pairs which are not unique. So that's how you get the answer 30.
All right.
Yeah. I hope.
Thank you.
Yeah. Welcome. Okay. Now the next question is in a skipgram model with a vocabulary size of 15,000, if you choose a negative sampling rate of 10 negative samples for each positive sample, how many total samples will be generated for a sentence with 8 unique words and a window size of 3? So how to approach this problem? First, we have to find the samples for this. So I have just taken an example, 8 unique words, A, B, C, D, E, F, G, H. There is a window size of 3. So you have to see 3 here and 3 this side. So for A, you get this, A, B, A, C, A, D, B, B, A, B, C, B, D, B, E, and you keep on making this. So you get 36. And they have said that negative sampling size rate is 10. So it means that for every positive sample, you select 10 negative samples. So number of negative samples will become 360. Positive samples are 36. So your total sample size will become 396. Is this clear, this concept?
Yes, sir.
Okay, very nice.
Sir, can I
Yeah.
the previous question? Like, I was
Yes.
getting 32.
So have you cut as late as?
Sorry, sir.
Have you cut this late as, and as late? Can you check your solution with this?
Okay, sir. As late. Okay, sir. Yeah.
Okay.
Yes, sir.
Yeah. Okay.
Thank you.
Sure. Okay, we move ahead now. Okay, so this is the next question. Assume that your CBOW model outputs a probability distribution
Same
over.
question as previous, sir.
Hello. Hello. Any question about that?
No, no, sir. This question is same as previous which we solved.
Okay, okay. Yeah. Oh, sorry. Yeah. Okay, this one is, we have already done this question, but it is a skipgram. Consider a skipgram model shown below. Each word in the vocabulary is represented as an one hot vector of size 100 into 1. The embedding dimension is 5 into 1. Enter the number of parameters. So see, size is 100, so this is 100 into 1. Embedding size, they have given 5. And they have also given that context words, how many? 4. So this will become 100, this becomes 100, 100, 100, and we have to find the total number of parameters. Quite easy, 100 into 5 plus 5 into 100 into 4. So this becomes 2500.
Just one quick question, sir.
Yes.
Like we have been asked to exclude bias.
Yes.
That was not there.
Because see, on a forward neural network, there can be a bias also.
Mm-hmm.
So specifically, we are saying that there is no bias. Okay, so only your weight matrix is coming, and weight matrix size is how much? 100 into 5. If the bias would have been there, then it would have become 100 into 5 plus 5.
Okay, got it, sir.
Okay, yeah, good. Okay, this is one question. This is straight away from the theoretical part. Okay, the professor had covered the derivation. So this is consider a model shown below. And what is the model? Learns the distributed vector representation of words by learning to predict the target word VW given the context word UC. Here VW and UC are the vector representation of the target word at index W of the output vocabulary and the context word at index C of the input vocabulary respectively. Suppose the input is X, one hot representation of the context word, and the corresponding label is Y, one hot representation of target word. The quantities H, UC, Y hat are computed as follows. H is equal to UC is equal to W context into X, Z is equal to W word into UC. This is incorrect. This will be H. Okay, so there is an error in the question. And Y hat is equal to softmax of Z. Choose the expression that the model has to minimize using cross entropy loss. So if you go to the lecture, the output Y hat, when you take like I had covered that here, this is the W context. So this is the Wth column and this is UC when you multiply by 1. This is W word, this is the row, this is the VW. So output Y hat is nothing but it is the softmax of this UC into VW because H becomes UC, here it is 1 and then you multiply by W word, so your here it is A, so A becomes VW into UC and output Y hat is equal to softmax of VW into UC. So Y hat is EUC, this is the softmax function. Now the loss we know for softmax is minus ln Y hat. When you solve this, you get this minus UC into VW plus log of this. So this is straight away from theoretical part. Remember this. So this is the correct answer. Okay. So it is again checking your concept. If you know the concept, you'll just stick it in 10 seconds, knowing the other options. So with this, week 9 is finished. Anyone having any other question? In the PYPs, these are the only questions which I could find. Or there were some questions which are of repetitive nature. That's why I have not covered them.
It's a small doubt.
Yeah.
If we like we had this question where we were to exclude the bias.
Yeah.
So if we include the bias, what will be the total number of parameters? Like
So that is a normal. So that is a normal forward. Okay, that's why I covered here. No, if you have got a bias here, and this size is 100, this size is 100, okay, and this size is, for example, 5. Now you tell me if there is a bias, what will be the parameters? It will be 100 into 5 plus 5.
There will be 5 bias terms in the embedding layer, and in the output layer there will be 100 bytes for each
Yes,
word, right?
yes. Okay, at this stage of the course, okay, you should be doing this. It's a normal forward neural network. Okay.
Yes, sir.
Okay, so generally in the word embeddings, okay, in the skip gram and the CBOW, the bias is not used. It is not serving any purpose. Okay. So I'm saying generally, but you're right. Okay, you should see the question. In case, okay, for example, they write okay, include bias, then you should be knowing. Okay. Okay. Thanks for asking this and clarifying. Anybody having any other doubt?
Sir, can you take question 5 from GA?
From the GA. So I will tell you the GA, especially the GA questions okay, of the week 9. There were some questions in which you need like, a coding.
Yes, sir. Yes, sir.
Okay. So without okay, those questions are not okay, which you can do in the quiz. Okay.
Right, sir. It was just that from the corpus, they were asked to change few things, and they're asking to calculate the PMI. But like I think we can do it without coding. Maybe like if you can just take a look at it.
Yeah. Okay.
Because
So can you send it to me? Okay. Or it is in week 9. Okay. Just wait. Okay. I'll just open it. I should be having. Okay. Week 9. Okay, which is the question?
the question 5.
But see, especially they have written specifically that calculations need coding. But by using the co-occurrence matrix created in question 3, compute the cosine similarity between the words in the vocabulary. While computing cosine similarity, ensure that each word vector is normalized to have a unit magnitude. So see, this again needs coding. You have to normalize and then find do the hot factor and all that. So
Right.
okay, so I don't expect this kind of question coming in your Anthem quiz where you need to do extensive mathematical calculations or to do coding.
Okay, sir. Just doubt on that. Let's say we have a corpus and it's the same as question 5, and they ask to calculate the PMI
Yeah.
or something like that. That can be calculated without coding.
Yeah.
And so there is a word and C, a W comma C pair.
Okay.
So we'll have to
Just hold on. So I will just give you an example. If we take this example, that's why specifically I had covered this example. So, for example, if you are given this example, in this case, if you are given in a corpus like this, can you find like a PMI? It is easily.
Yes, sir.
Okay.
So just one thing, sir, I was not here when you discussed this. So there is some pair that we have to find PMI of. So we'll take the order as it is, right, sir? We won't see if they are asking PMI of W comma C.
They
We'll
will.
take that order also. We'll not take probability of pair C comma W.
No, it is not the probability. The formula for PMI is the count. It is log count of WC, how many times WC they have occurred together, okay, in that window size, into n is the number of words, divided by how many times W has occurred and how many times C has occurred.
Right, sir. I like count. Yeah,
Okay.
so we'll take the order too, right?
Yeah. So, for example, in this corpus, this was the corpus, and we said okay, that we will ignore the stop words. So then we got this, and we said window is equal to 2. Okay. So then we found okay, these are the occurrences which are happening. Delhi capital, Delhi India, Delhi Paris, Delhi resembles. And we found India and France, okay, for example, they are occurring twice. And we have to find, for example, PMI of India and France. Okay. So India and France, they are occurring 2 times. Number of words is 7. India is occurring in this corpus 3 times. France is occurring 3 times. So answer becomes log 14 by 9, which is 0.5. So if a question comes in your quiz, they will give you a corpus, Okay, from there you have to build the walk-up size. First you have to build the co-occurrence matrix, and then from the co-occurrence matrix you find the PMI.
How we find count of W comma C?
How do you find a case? So India and France, they have occurred here.
Okay, okay. So together, how many times it occurred?
Yeah, and India and France, they have occurred here.
Okay.
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 Yeah. Any other question on this? Or shall we move to week 10? Okay, so if there is no further question, we move to week 10. So week 10, I will not cover the concepts because concepts are quite clear. Just main concept, recurrent neural network. We know that there is a state vector, which is S. There is an input and there is an output, Y hat. And they have got associated weight matrices, U, W with the state vector, and V is with the between the output and the state vector. And at every stage, we keep on getting the Y hat. And how do we calculate the SI? SI is state vector is calculated as sigmoid or 10h of W into SI minus 1 plus UX plus bias, which we consider B, and Y hat is taken as softmax of V into SI plus bias C. So this is the forward propagation. In the back propagation, what do we do? There are two types of losses which come. One is coming from the last one here, and we keep on accumulating the loss, and we take the derivative and we update W, U, and V. However, RNN faces a problem of either exploding gradient or vanishing gradient. Vanishing gradient, why it happens? Because it is passing through the sigma derivative to every stage, and we know that in sigma there is a probability that it becomes 0. Exploding, because it is again a sigmoid, sigma minus sigma, and if your W's are higher, then they will explode again. Your gradients will explode. And to solve that, okay, we have got LSTMs where we have got input gate, we have got forget gate, and we have got output gate. We have got a GRU where we have got the reset and another gate, which I'll explain. So with this, okay, without going much more into the concepts, I will straight away come to the PYPs because here there are certain interesting questions. So here is one question. Given a scenario where there are 8 possible letters represented as one hot encoded vector of length 8, the RNN employs the following formulas for the state vector and output at the time step t. So this is same st is equal to sigmoid of uxi plus wst minus 1 plus bias, and output is y hat is equal to softmax of vst plus c. So sigmoid and softmax. The state vector size is 2 and y hat size is 8. So that we know if they would not have given, then from here also we can make out. Okay. So with a total 20 time steps, t is equal to 20, implying prediction for a word of length 19. What is the total count of parameters, including bias, within the network? Can somebody help me in this? How to find?
So we have 8 possible letters. So it 8 times 2 is there. Then there is a 2 cross 2 of W vector, W weight matrix, and then we have output weight to output, and then we have bias for U and bias for B and C.
Yeah, very nice. Thank you. So remember in RNN, these weight matrices which are there, U, V, W, they are shared. Okay. At every stage, you are using the same U, V, W. So here they have given the size is there are 8 possible letters represented as one hot encoded this. So the size of this will be how much? 8 into 1. The state vector size is 2 into 1. and the output size is 8 into 2. Is that clear? Sorry, 8 into 1. Is this clear?
Yes, sir.
Okay. Now we know here we have got W, here we have got U, and here we have got V. And we know that the formula for ST is sigma UXI plus W plus B. Okay. Now W size is 2 into 2. W size is 2 into 2. U size is how much? 2 into 8. And V size is 8 into 2. Now what will be the bias size again? B size? It will be 2 into 1. And what will be the size of C? 8 into 1. So your total number of parameters become 4, 16, 16, 2, 8. So this is how much? 16, 4, 20, 36, 38, 46. Is this clear?
Sir, can you explain the diagram again?
Okay, so this is your state vector. For example, we starting from S0. Here we come to S1. This is your X1. This is your Y hat 1. And now you keep on going all 20 steps. But your parameters which are there, they don't change. The parameters, they remain the same.
Yeah.
So they have asked the total number of parameters. So with UW, there is a bias B. With Y hat, there is a bias of C. W size is, we are feeding a 2 into 1. So W will become 2 into 2.
Yeah.
You are feeding 8 into 1 to get 2 into 1. So U size is 2 into 8.
And this ST is predicting the output, so 2 into 8.
This is 8 into 2. Okay.
Yeah.
Now this B size becomes 2. 2 into 1.
Yes, B size become 2 into 1.
And C size becomes 8 into 1.
Yes.
Okay. So this is how you get the number of parameters.
Excuse me, sir.
Yes.
Sorry, but can you repeat for the W1?
For W.
Yes, sir.
So you are feeding state vector S0, size is 2 into 1. You get S1, which is the size is how much? 2 into 1. So it's a 2 into 1. You are feeding into 2 into 1. So what will be the weight matrix here? 2 into 2.
Yes, sir. Thank you.
Okay. Okay. So kindly mute your mic, please. Okay. So this I have explained. Now if all the parameters, including bias in the network, are initialized to 0, what will be the predicted y hat 2 at time step 2? Assume that indices start for the input 0, 0, 1, 0, 0, 0. So can somebody quickly give me, it is a 30 seconds answer. U is equal to 0, B is equal to 0, W is equal to 0. So what will happen to ST, S2? This becomes 0. Hello?
Yes, sir.
Sigma of 0. Okay?
Yes, sir.
Including, but when you sigma of 0 multiply by V is also 0. So your A at the Y hat, which is going, again, we go to the same diagram, or I will make the diagram again. Here you get 0 because V is 0. So softmax, now the output Y hat is equal to softmax of 0, 0, 0, 0, 0, 0. Is that okay?
Yes, sir.
But when we compute sigmoid of 0, it becomes, I think, 0.5, sir.
So again, you multiply by 0, na? V is also 0.
Okay. That's
Okay.
right.
Okay. So that's right. So softmax is 0, 0, 0. And we know that, okay, how much it will become? It will become 1 by 8, 1 by 8, 1 by 8. Okay.
Yes, sir.
So see the questions, like I have been saying in earlier quiz revision sessions also, look for the concept. Okay? And once you get the concept, then they become just 30-second answers. Okay, now you come to the third part of the same question. If all the parameters including bias in the network are initialized to 0, what will be the total loss after 20 time steps? Assume that indices start with 1 for this. Assume the loss to be cross entropy loss at each time step. So can somebody tell me, knowing the concepts of RNN, what will be the total
Uh,
loss?
After calculating the first loss by minus of ln of that y hat multiplied by 20 times step.
So this is the answer.
Yeah.
So straight away, see, very nice. Okay. So you knew the concept and now you can solve it in just 30 seconds. Okay. Okay. Anyone, any doubt in this question? So these questions might look tricky to you, but once you apply the concept, you immediately get the answer. Anyone wants me to repeat again this question, entire question?
So, is it possible to repeat just the formulas and once for this?
Okay, so formula in a RNN, ST is W into ST minus 1 plus U into XI is input, plus B is bias. Is this clear?
Yeah.
Okay. And Y hat, and this can be sigmoid or 10H. Okay. Y hat is softmax of V into ST plus C. This is the formula. And if you are utilizing softmax, then your loss is minus ln of y hat I at that step.
Hmm. All right.
Okay.
Thank you, sir.
Yeah. And in RNN, what happens that your loss which is coming, it keeps on accumulating. So at every stage here, your loss will be accumulating till here. So in this particular question, at every place, your loss was minus ln of 1 by 8. And there are 20 time steps, so you multiply it by 20.
Hmm. Because it's sequential, right? That's why it's accumulating.
Yes, yes.
All right. Thank you.
Yeah, welcome. Okay, so now there is another question. We solve this. Suppose that we need to develop an RNN model for sentiment classification task. The input to the word is a sentence composed of 10 words, and the output is the sentiment positive or negative. So it will be either 1 0 or it will be 0 1. Assume that each word is represented as a vector of length 100 into 1. This is the input. The output labels are one hot encoded, which I have already done. Further, the state vector st and the prediction y hat t are computed as follows. The same, they are using sigmoid and softmax. The state vector st is initialized with all zeros of size 15 to 1. Okay, so what is the setup again of this question?
We have to diagram as a previous one.
Yes. So this is 50 into 1.
Yes.
This is 100 into 1.
1.
This is W. This is U. Here is V. And the output is 2 into 1.
2 into 1.
Okay. And bias is there and is there for both. So calculate the total number of parameters. Now you should be doing fast. W will become how much?
50 cross 50.
Very nice. U is
100
cross
50.
50.
V is
50 cross
50 cross
100.
2.
250 cross 2.
very nice. B is
B is the size of U. So it will be 50.
Given the
B
size
is
of ST.
100.
15 to 1. Is that okay?
Yes,
B,
sir. 15 to 1.
Yeah,
yes. And C is?
and C is the size of so 2.
C is 2.
Okay. So you calculate this, you'll get the answer. Total number of parameters. So this becomes 2,500, 5,000, 15 into 200, 52. So 256,765 is the answer. Okay.
Yes, sir.
So I hope all of us we are comfortable in solving this kind of question now. We can solve the number of parameters.
Yeah.
Yes, sir. Yes.
Okay, very nice.
Yes, sir.
So we go ahead. Okay.
Excuse
Yes,
me,
yes,
sir.
please.
So W vector is always a square matrix, am I right?
Yeah, W will always be a square matrix. You're right. Because S0 is coming and S0 and S1 size is same.
Okay. Thank you.
Yeah. Kindly mute your mic, please. Okay. So now we go to a question which is much more involved and it will check our concepts also and calculations also. So in this question, they have given an RNN model. This S0 is 0, 0, which happens in RNN. The first state vector is generally 0. There are two inputs, x1 is equal to 1, 0. Second input, x2 is equal to 0, 1. There is no output in the first stage. In the second state, the output is y is equal to 0, 1. Actual y. This is actual y. In the question, they have given that weight matrices UVW are initialized as same 1 minus 1 minus 1 1. The state vector ST is computed as follows. So instead of sigmoid, here it is tan h uxi plus wst minus 1. There is no bias. What is the loss value? Use cross entropy loss with natural logarithm. In all your calculations, consider only the first two decimal places for this. And so if there is a cross entropy loss, it means in the output what we are using. Can somebody tell me what is associated with the cross entropy loss?
Softmax.
Very nice. Very nice. So this is the basic setup. So how to set up this question and how to solve it. I'll explain this. So again, what we have to do, diagram is already given to us. So we have to calculate first S1. So S1 formula is given tan H UX1 plus WS0. So this is tan H, put the value of U 1 minus 1 minus 1 1 into 1 0. S0 is 0 0, so this becomes 0. So here you will get the value of S1. Something will come of size 2. Now use this S1 to calculate S2 because here there is no output here. So now S2 will become tan H of UX2, which is 0 1, plus here, now this part will not become 0. Here you will multiply this by 1 minus 1 minus 1 1 and the value which you have got here. So again you calculate the tan H of that and you will get the values. Dimension is 2 into 1. Now for y hat you have to do softmax of this value which you got multiply by 1 v, which is 1 minus 1 minus 1 1 into this S2 which you get. So this softmax when you apply you will get some find value. Now you know that y is equal to 0 1. So this part which you will get, this will contribute towards loss and your loss will become minus ln of this particle. So this already I have done the calculation. Any confusion regarding the steps which I have covered? Here, how to calculate?
No, sir.
Okay. So see calculations I have done. So the concept I have covered. So S1 is tan of this is u into x1 plus this is 0 0 because s0 is 0. So you get tan h of 1 and minus 1, which is 0.76 minus 0.76. S2 is equal to tan h of u into 0 1 x2 plus w into this s1. So here you get tan h of 0.52 minus 0.52, s2 is 0.47 minus 0.47. From here you calculate y hat is equal to softmax of v into s2. V is this is s2. So you get softmax of 0.94 minus 0.94. You get the value 0.87, 0.13. Actual y is equal to 0, 1. Therefore, your loss is minus y ln y hat. So this becomes minus ln 0.13. Answer comes 2.04. So this kind of question has been asked repeatedly, and I can share from my personal experience. This is the most evolved question which can be asked regarding RNN. Okay, and is that clear? This calculation part is clear? Anybody having any doubt in this?
Sir, after this 0.94, how it converts 0.87 and 0.13?
Softmax. What is the softmax? E to power 0.87 divided by e to power 0.87 plus e to power 0.13 is 1. And second will be e to power 0.13 divided by e to power 0.87 plus e to power 0.13. Is that clear? This is the softmax function?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Sir, is the question asking the loss for the final step or the total loss?
See, here in the diagram itself, they have given that okay, loss is happening here only. There is no output here. Okay.
We'll have to answer according to the diagram.
Yeah. And otherwise also, if there was an output here, they will specifically ask you what is the loss at S2. Okay. Is that clear?
Okay, sir. Thank you.
Yeah. Okay, so this we have solved. This question I'll leave it to you. It is again a simple question, and we have solved this question just now on the same concept. Consider RNN shown below. X0 is given, X1 is given, X2 is given, U is given, W is given, V is given, S is equal to 0, S0 is 0, and here this is tan h function, and you have to true level is y is equal to 1. And on the same concept, here the calculations are slightly easier because there are no matrices. Here there are straight away scalars. So you calculate S1, you calculate S2, you calculate S3, and from S3 you calculate y hat, and then from y hat true level y is 1 is given. So and the loss is MSE, and you calculate the mean square error loss. So this is. So what I've seen in PYP is this one kind of this question comes. There is another question which you should be ready. They might ask you that there is an RNN, so there are states are given, and they might ask you that actual y is, for example, 1 0, and when you solve this, you will get some y hat. Okay, they can ask you update v. Okay, because to update W and U, you have to accumulate all the loss till the first state. So generally it is not asked here because it is a lengthier process. But for V, you can straight away, you can use this loss only to update V. So I hope you will be able to update V. What is del L by del V? Anybody can tell me? If it is a softmax.
So it will be softmax, then it will minus cross. We will use cross entropy loss.
Yes,
and
yes.
then multiply by the input of V.
Yes. So we know del L by del A by del S. Okay. For example, here this is ST, or this will be del B. Okay. So del L by del this. Okay. What is the value of this? It is y hat minus y. It is y hat minus y.
Right.
Yeah.
Okay. And del A by del B, we know that A is equal to B into ST plus C. So this becomes straight away y hat minus y into ST. So this is the maximum which they can ask. So calculate this and then you update the V. Okay. So in one of the PYPs which I can remember, they have asked this question. So with this, I have finished. Okay, any question you can ask me now. The week 10 also. Okay, can I ask you one question? Simple question from RNN. Okay, so we know RNN, they face a problem of vanishing gradients and exploding gradient. So with LSTM and GRU, which of the problems are solved?
Vanishing gradient problem.
And why not exploding gradient?
Because during back propagation, the weights are going to reduce.
So what do we do to reduce this problem or to obviate the problem of exploding gradient?
Clipping.
Gradient clipping.
Okay, gradient clipping is done to solve the problem of yes, for both. Otherwise, okay, when we select the initial W's, W, U, and V, so we don't select large values. We select small values, so they will not explode. Okay.
Sure.
Okay.
Okay, so that was from my side. Okay. So any question, any doubt, any clarification from week 9 and week 10? We have solved mostly all the PYPs. Some PYPs I have left, which were simple ones, from understanding point of view. These are the ones which are more evolved and from the concepts. So these we have solved. So in case of any doubt, please ask me. Hi, Loveleen. How are you? Abhineet, Garima, Nitesh.
Yeah,
Aniket?
good.
Yeah.
Good,
Yeah, good, sir.
Good session.
It was fantastic.
Yeah, good.
Good,
Thank you, sir.
Sir, one thing, sir, can you share the slide link?
Slides.
Okay, this PDF document, what I will do, this PDF document I will share on the WhatsApp group.
Okay, sir.
Yes, sir. Yes, sir.
Okay. So
Yes,
just
sir.
yeah.
Thank you, sir.
Thank you, sir.
Chalo then, good night and all the very best. Take care. So remember, find the concept which is being used in that question. Have confidence in your abilities. If you are knowing the concept, you will be able to do it. Happen. Okay.
Sir, for tomorrow's session, what we are going to do?
Tomorrow, really, I'm not aware. Okay? I was given the task of conducting this session. So maybe I think week 12, okay? I think week 12 revision session has not been done.
So Lalit, from week 11, 12, it'll be mostly some kind of objective type, that definition kind of question, or?
So I'll share my experience. Till our term, they had not asked any calculation part from week 11 and week 12. And week 11, if you go through the material, it is basically understanding that what kind of decoder encoder you are using. Okay. And week 12, there might be some questions, so you might go through your PAs and GAs of week 12. Only that kind of question.
Okay.
Chalo, thank you. Have a very nice day. All the very best.
Okay.
Good night,
Thank you,
sir.
Lalit.
Bye.
Thank you,
Bye.
sir.
Thank you, sir.
Thank you, sir.
Bye. Bye, Anand. Anand, how are you?
Sir, can we get recording also?
Yeah, it has been streamed on YouTube live. So that link also Nitin has shared. It is there in the chat.
Okay, sir. Thank you.
Yeah. Okay. All the very best. Thank you.
Thank you, sir.
Bye-bye. Have a nice day. Bye.